Well, we're back, and we are back with a bang. We're going to hear about Cambium's special relationship with Facebook. And joining me is Neeraj Bhatia of Terragraph Facebook. And here he is. Hi, Neeraj.
Hi, Brian. How are you?
I'm very well. We're looking forward to your presentation today. Now, you're going to be joined by our very own Anthony Holmes. But for the time being, I'm going to leave the stage to you. Can't wait to hear what you've got to tell us.
Thank you so much. I'm delighted to be sharing the stage here with Anthony to talk to you about Terragraph and Cambium cnWave offering. Please let me start the Terragraph story by sharing this video with you. If you can cue that in, Brian.
We want to enable more affordable access for everybody in the world. And so what we're trying to do is figure out how do we create high-speed internet for all. That's our key objective here. You have this incredible capacity and speed of fiber. In some cases, it can be very expensive. And then on the lower cost technologies, which are low cost to deploy, but they do not have the sort of future proof in terms of internet capacity that's possible. And so Terragraph is meant to address that gap.
Terragraph is a specific technology which operates in 60 gigahertz unlicensed band, delivering fiber-like speeds. So for the markets where fiber access is prohibitive and costly to deploy because of factors like trenching and permitting, etc., Terragraph can be a better alternative to provide broadband connectivity at much lower cost. It can be brought to markets in a matter of weeks. As you can see, all four of them are oriented in different directions. Each of them can beam multi-gigabit capacity to another sector. That would beam to another sector. They together create a robust distribution network that can scale up as network demand grows.
Key advantage for Terragraph is ease of deployment. You design boxes that you need to mount somewhere. We use infrastructure which already exists. We use street poles, rooftops. You mount hardware, you interconnect boxes with the gigabit speeds. It's already like a notion of fiber in the air. And then you take all these links and then interconnect them in a bigger mesh. And they basically have really scaled deployment in the big area, provide wireless connectivity at the gigabit speeds at fast, economical way. We basically created a lot of innovation on top of some of the existing IEEE standards and existing chipsets, and then we work with partners to contribute that innovation back to community with standardization, with the latest IEEE 8.11ay standard. And that basically creates evolution path for this technology to be further developed. With Terragraph, like with any other new technology, to create market around it requires really a rich ecosystem of players. We are working with some of the leading industry manufacturers' equipment to help us bring Terragraph technology and products to the market.
Our mission is to bring more people online to a faster internet, and the faster internet is a key thing for us. So we believe that the internet needs to be affordable for all, it needs to be available and relevant for as many people as possible, but we want to make sure that it's high speed as well. We think that everybody around the world deserves and should have the opportunity to be able to get the full richness that the internet offers. And so Terragraph technology is one of those key components we think that is required to bring high speed internet to as many places as possible.
Thank you. So everyone in this audience understands that fast and reliable access to internet is absolutely vital to our economies. At Facebook, as we grew through our family of applications, we learned that connectivity is critical to providing immersive user experiences. And one of the biggest challenges, as we saw, is around delivering this last mile connectivity. If you look at the globe, there's more than 1 billion people who rely on outdated infrastructure. In many cases, it's copper-based. It does not scale to meet the growing demand from the market. Fiber footprint has been steadily expanding, which is great, but the biggest challenge still remains. You still have to trench, you have to get permits, you have to lay cables, which makes it cost prohibitive for an operator to deploy at scale. We at Facebook Connectivity are precisely trying to address this gap, for which we have developed Terragraph. We've built a strong ecosystem with fantastic partners like Cambium, Qualcomm, and others to provide a solution to extend the current fiber deployments with a wireless fiber solution. I do want to mention that we're not a service provider, we're not an OEM either, and we're not a systems integrator. We developed the core Terragraph technology and licensed it freely to Qualcomm and other OEM ecosystem partners to take Terragraph to market. So what is Terragraph? I'll just give you the high points first. Terragraph is a multi-node wireless mesh technology which has been designed to deliver reliable high-speed connectivity. It uses license-exempt 60 GHz frequency band to deliver gigabit speeds to end consumers. It uses an open source mesh solution to achieve high reliability. Terragraph is much lower cost than the alternatives for fixed wireless access and is really easy to deploy. It can be brought to market in a matter of weeks, and we've seen that time and again in some of the deployments I will talk about shortly. Terragraph uses up to 4 contiguous 2.16 GHz frequency bands. With channel aggregation, you can combine 2 of these bands together, and you can deliver bi-directional data rate more than 5 gigabits per second per sector. So, as Anthony will show later in the presentation, with multiple sectors, you can build devices that serve over 10 gigabits of capacity, aggregate capacity in the network. The Terragraph mesh is based on the OpenR protocol. This was a protocol that we developed at Facebook for efficient routing in our data centers, and it has now been open sourced. So why is the mesh so important when you're deploying millimeter wave networks? The mesh efficiently distributes capacity between nodes based on demand. There have been other layer 2 solutions previously in the market, but they don't scale. When each node in your network is a layer 3 router, you can essentially scale the mesh infinitely. Now, we've done tests for up to 15 hops in a network, but the mesh also allows you to segment the traffic much smarter. It overcomes the line of sight concerns that you typically have with millimeter wave, and it quickly redirects traffic in case you have a broken link or if you have some RF impairments. In Penang, in Malaysia, we've deployed a commercial network with hundreds of nodes spanning 4 square kilometers, deploying a large-scale mesh using OpenR. Now, the TDD framework in the MAC layer helps you scale. It helps you deploy networks at very high density. It is true we're using the 60 gigahertz band and it is license exempt, but Terragraph allows you to use a single frequency network for a very dense deployment, very efficiently utilizing the spectrum. So operators can compete by offering symmetric services that are much needed by not only enterprises, but even consumers today. In addition, we offer cloud management solutions that allow you to do topology management, inventory management, visualization, alarms, and we offer network planning capability. We learned very early in our designs that millimeter wave networks required sophisticated network planning, and we enable network planning and cloud management capability through our OEM partners, and Cambium is also offering that as a part of their portfolio. Essentially, Terragraph is built on existing IEEE standards 802.11ay, and it's a culmination of significant innovation, not just from Facebook, but also other ecosystem players like Qualcomm, Intel. Let me walk you through with a few scenarios. These are different archetypes when it comes to deployments that we are seeing in the market today. We see rooftop distribution. So this is very typical on the left side, where you see single-family homes and businesses using perhaps a side-mounted radio on the roof or the building facade. We've had these deployments happen with common networks in California or YTL in Malaysia. Now, the second one is using street assets. It's using lampposts or other street furniture. We've had these deployments. We deployed such a network in San Jose. This was a 500 node network, and this deployment involved a very strong public-private partnership with the city, and we have seen this model be repeatable in Ohio, and it is essentially tied to what you see traditionally in residential fixed wireless access. The third one on the right is about MDUs. By using an existing structure for in-building wiring, it could be copper, it could be coax, we can put a single client node on top of the building and share that capacity through the MDU. This is by far the lowest cost solution to deploy Terragraph to hundreds of people. Finally, we see a lot of deployments addressing rural clusters with micropop solutions from Cambium using their long-range products like the V3K. We have the ability to address the rural market. Now, Facebook has conducted millimeter wave fixed wireless access trials globally. We've demonstrated the efficacy of the millimeter wave band, and we've collected a lot of feedback. To date, including commercial networks, we've had customers in over 5 countries in 4 different continents, variety of rain regions. We've learned that connecting high-speed millimeter wave broadband can be done very quickly. It needs to be planned, but it can be really fast in a matter of weeks. OEM partners and systems integrators can work very closely with operators to help with network planning, integrate the OSS, BSS systems into existing deployments. And that is very doable given the framework that Facebook offered through OEMs. Overall, operators have been astonished at the simplicity of the system, and they're pleased with the customer feedback that you're getting with gigabit service. Now, I'm going to hand off to Anthony here. Want to leave you with a little bit of a synthesis. So first, Terragraph is fast. You can offer symmetrical gigabit services at very low latency with carrier-grade reliability. Terragraph is affordable. With reduced capex and time to market compared to fiber and unlicensed spectrum, Terragraph offers a very, very attractive total cost of ownership for small and large operators. Terragraph is standards-based. It's based on the IEEE 802.11ay specification. It leverages Qualcomm's millimeter wave expertise. Finally, Terragraph is versatile. You can address fixed wireless access, smart city, mobile backhaul, all these use cases in dense urban scenarios, or you could even address rural clusters. Finally, OEMs, Cambium is ready. They have commercial product available, and they're ready to work with you to deploy large-scale millimeter wave networks. With that, I'm going to hand it off to Anthony.
Thank you, Niraj. It's been 2 years in the making. We first met at TIP in London 2 years ago, and the whole idea and concept of Terragraph was sold to us, and we bought in big time. Cambium is loving this technology, loving the ability to work with you and to deliver this to our customers. So thank you for that.